All right, so this is our last video in just 11.1. Sorry, there's a lot of videos, but hopefully they're relatively short. In this, we're going to talk about unit vector. So we just want to understand what is a unit vector and how to find a unit vector in the direction of a given vector. A unit vector is a vector that has a magnitude of 1. Remember, magnitude is the same thing as length in terms of generic vectors. Once we get to applications, that could be slightly different. But it's a vector with a magnitude of 1. Think about, and that should make sense because think about what else uses the word unit. That's right, very good. The unit circle. Remember, one of the top 3 circles in the universe? Yeah, unit circle. So, and why is it called the unit circle? It's a unit circle because it has a radius of 1. Unit vector, vector with a magnitude of 1. Okay, so we have our unit vectors I and j, where I is the unit vector in component form, written like this, 1, 0. In rectangular form, it would be I plus 0j. And then we also have the j unit vector, which in component form is 0, 1. And in rectangular form, I'm going to call it something else, so let's call it w, would be 0, I plus j. And so all these are the generic vector. 1 unit up would be the j vector, j unit vector, and 1 unit horizontally would be the I unit vector. So the big thing we want to use or get from this, though, is being able to find a unit vector that has the same direction as a given non-zero vector. So for any non-zero vector v, the vector v over the magnitude of v is going to give you a unit vector that has the same direction as v. So to find this, we divide vector v by its magnitude. And when we say we divide vector v by its magnitude, we're just dividing each individual component by the magnitude. This should make a lot of sense because think about similar triangles. You know, if I have some, let's just draw a scenario. So if I have this is the magnitude of some vector v, and it has this is its a component and this is its b component, so v equals ai plus j, and then I want to find a vector in the same direction as this, but with a magnitude of 1. So how do I find this, let's call it x and y component? Well, I can just set up a simple proportion. I know that the direction has to be the same, right? Because that's what I want. So these are similar triangles because all of their angles then have to be congruent. That's a right angle. So I can set up the simple proportion that a over magnitude v has to equal x over 1. And that's essentially what this is doing. This is just saying take the entire vector because you're going to divide each individual component. Okay, moving on. So that's how we find a unit vector in the same direction as a given vector. So now let's try an example of this. So find a unit vector in the same direction as the vector v equals 4i minus 7j, and then find the direction as well. So we talked about this on the previous video. How do we find direction of a vector? So I want you to pause the video and try and do this. Unpause when you're ready to check. All right, so hopefully you came up with the unit vector in the direction of vector v is going to be 4 over the square root of 65i minus 7 over the square root of 65j. If you rationalize these numbers, that's fine as well, but you don't have to. The direction of vector v is 299.745 degrees. So let's talk about how we get this. Well, first we need to find the magnitude of vector v. So the magnitude of v is the square root of a squared plus b squared, and that's how I get the square root of 65. So then remember, a unit vector in the same direction as a given vector is the vector divided by the magnitude of the vector. So 4 divided by square root of 65I minus 7 divided by square root of 65J. Then the next part, to find the direction. Well, remember we learned in the last video that the tangent of theta, where theta is the direction angle, is going to equal b over a. So I have tangent of theta is negative 7 over 4. This is where I have to use a little bit of my trig knowledge. So where is this vector 4i minus 7j? Remember, this is the y component, this is the x component. So this is going to be 4 to the right and 7 down. So I know that I'm going to be in the fourth quadrant. However, when I do the tangent inverse of negative 7/4, I'm going to get what I'm going to call theta prime. Theta prime, in this case, is not exactly my reference angle because it's negative, but it's going to relate to my reference angle. What I do need to think about is the range of the tangent inverse function and the fact that when it gives me negative 60.255 degrees, I know that that is a negative angle in the fourth quadrant, and in this case, that is okay in terms of the vector is in the fourth quadrant. However, I don't want the negative angle, I want the positive angle because I want to go counterclockwise from the positive side of the x-axis. So what do? I find a coterminal angle of this. So I say theta, which is the actual direction that I want, is theta prime plus 360 degrees. So theta is going to be 299.745 degrees. Last thing we're going to talk about very briefly is what's called the zero vector. So the vector whose magnitude is 0 is called the zero vector. The zero vector is assigned no direction. Keep that in mind. That will be important when you're doing problems involving the zero vector. It can be expressed in terms of I and j using 0 equals 0i plus 0j. All right. So vectors are a directed line segment. Most important thing we need to understand in this unit because it's going to help us do applications with vectors. A unit vector is a vector of magnitude 1. Magnitude represents length. It comes from the distance formula. We still need to know our trig and how angles work on a coordinate plane in terms of trig. Keep that stuff in mind. Which quadrant should something be in versus which quadrant is an angle turning up in. Those are all things that you're still going to have to think about.